Welcome to lesson 5.2, guys. This is the lesson on numerical expressions. This is on page 269 of volume 2, Reveal Math, course 1. This is the first module in this volume 2 book, like we used yesterday when we did 5.1. And today's slides, if you will, they're not slides. It looks a bit different because the slides that Reveal Math provided had an issue. So I'm going to be going over this lesson in Reveal Math. So we're going to do things a little differently. The check problems don't show up the same way. So I will just pause the video for you to work on the check problem on your own. And I'll share the solution with you. And let's see, there will be some extra apply problems, extra example problems, which I will share with you, but I will not show the solution right here. We can work on the solutions in class if you wish to, but those are just for your optional practice if you want. Let's see a quick warm-up. Pause the video right here, and then I'll share the answers with you. Here are the answers. The answer to the last one, unfortunately here it overlaps with the question. The answer is 4.5 days. Let's move on. Here are the standards. You can pause and read the standards if you wish to, or else I'm going to keep moving. These are the standards for mathematical content. And here we have the standards for mathematical practices. What are the main vocabulary that we're going to learn as part of this lesson? We're going to learn evaluate, numerical expression, and order of operations. See, what are numerical operations? A numerical expression is a combination of numbers and at least one operation, like 4 squared plus 7 divided by 3 minus 1. To evaluate a numerical expression, we find its value. A numerical expression can be evaluated using the order of operations. The order of operations are the rules that tell you which operation to perform first when more than one operation is used, and this guarantees that the value that we find each time we evaluate the expression is the same each time that we evaluate it. So our order of operations is we first simplify expressions inside of parentheses. Next, we find the value of all powers. And then we multiply and divide in order from left to right. And then we add and subtract in order from left to right. So when these two operations follow each other, like multiply or divide follow each other, and the add or subtract follow each other, we do them from left to right. They both have the same priority. Let's use the expression, this is the talk about it on the bottom right of page 269. Use the expression 12 plus 3 times 4 to explain why we need rules for evaluating expressions. And the order of operations gives us a certain order to follow. If we did not follow that, if we solve this from left to right, what we would get is 12 plus 3 is 15 times 4 is 60. However, when we apply our order of operations, we multiply the 3 by 4 first. That yields us 12, and 12 plus 12 is 24. So you see how you could get two different values. Let's take a look at, before I forget, here's another mnemonic that we have learned in the past. Some of you might have learned, some of you might not. It is, please excuse my dear Aunt Sally. The first letter of each of these words tells you which operation. So please, the P stands for parentheses. We do that first. In excuse, the E stands for exponent, which we do next. M stands for multiply, D stands for divide, A for add, and S for subtract. So that's our order of operations. Now let's evaluate the expression 100 minus 3 squared times 6 plus 4 plus 2. This example 1 is on page 270 of your book. Now think about it. What does the order of operations tell us to do first? Well, it tells us, like PEMDAS, it tells us the parentheses gets evaluated first. So we're going to first simplify what's inside the parentheses. So 6 plus 4 simplifies to 10. And then we evaluate the exponent, which is 100 minus 9 times 10 plus 2. So that gives us, when we evaluate, our next step is going to be to multiply. So that gives us 100 minus 90 plus 2. And then, even though normally in the order of operations, add comes before subtract, but when they follow each other like they do in this case, we're going to evaluate from left to right. So we do 100 minus 90, that's 10, plus 2, that gives us 12. And we just answered this talk about it. Explain why subtraction was performed before addition when the expression showed 100 minus 90 plus 2. It was performed before it occurs earlier in the expression before addition. And according to the order of operations between add and subtract, you perform them in order from left to right. Oh, that would be the check problem. Pause the video here, guys. Do the check problem on your own, and I'll share the solution. The solution to the check problem here is 24. Here's another extra example problem for you to practice if you wish to. 20 times 6 minus 2 within parentheses divided by 2 cubed plus 1. Let's see, moving on to example 2. Example 2 is to evaluate 5 plus 8 squared divided by 2/5 times 2. Now again, we're going to follow our order of operations. We evaluate inside the parentheses first, and within the parentheses again we have an expression. It's 8 squared divided by 2/5. So we're going to apply our PEMDAS rule. Parentheses exponent, so we resolve the exponent inside the parentheses. So that gives us 5 plus 64 divided by 2/5 times 2. 64 divided by 2/5 is 160, which, because that's 64, it's equal to 64 times 5 by 2. So 64 by 2 would be 32, times 5 is 160. So what we have here is 5 plus 160 times 2. 160 times 2 evaluates to 320. So we have 5 plus 320, which is 325. Again, pause the video here for a moment. Work on this check problem on your own. I'll share the solution. So the check problem here, again, this is the question at the bottom of page 270, which is 8.2 times, within parentheses, 2 to the power 4 minus 3 plus 8. The answer is 114.6. Moving on, here's another extra example in case you want to practice. Evaluate 48 divided by, within parentheses, 2 cubed divided by half minus 1.7. Write your answer as a decimal. Moving on, we're going to look at a real world situation where one or more operations occur and we write expressions to represent the situation. So let's look at our issue here. Mariana and her friends are buying snacks at a hockey game. Hot dogs here cost $4. Boxes of popcorn cost $2 and drinks cost $2.50. So we have to write an expression to represent the total cost for 4 hot dogs, 3 boxes of popcorn, and 2 drinks. So if you can see, the price per hot dog is $4 and we have 4 hot dogs. So we put that within parentheses because that is the price of hot dogs, plus the price of popcorn, which is $2 times 3. Again, we put this part within parentheses. And then the price for drinks is $2.50 times 2. So our expression here is $4 times 4 plus $2 times 3 plus $2.50 times 2. Now let's look at the talk about it here. How else can you represent the part of the expression that is written as 4 times 4? We just learned this in the previous lesson. It's 4 squared. All right, so that was writing a numerical expression. So next, in example 3, we're going to look at writing and evaluating numerical expressions. So let's look at the question we have here. Paula is shopping for items shown in the table. We have to write an expression to represent the total cost for 5 lotions, 2 candles, and 4 lip balms, and then find the total cost. So we can see here from the table the cost of each lotion is $5, each candle is $7.80, and each lip balm is $2. Actually, there's a typo here in this table. It's $2.49. According to your book, we'll follow the value given in your book. Think about it. How are we going to write an expression to represent the total cost? We tackle them one at a time, one step at a time. So we're going to look at the cost of lotions, plus the cost of candles, plus the cost of lip balms. Now the cost of lotions, you can see if she buys 5 lotions and each is $5, so that's 5 times 5, or can be represented as 5 square. Plus the cost of candles, she buys 2 candles times the price of each candle, which is $7.80. Plus the cost of lip balms is she buys 4 lip balms, that's 4 times $2.49, which is the cost per lip balm. Next, we're going to move through the steps to find the cost of each type of item, and then we're going to find the sum. So 5 square we know is $25. 2 times 7.80 is 15.6. 4 times 2.49 is 9.96. So we have 25 plus 1560 plus 9.96. We add them, our total is 50.56. So the total cost that we have for these items is 50.56. Let's take a moment, do this talk about it on your own. This is on the bottom right of page 271. Then I'll talk about it. So let's see, in this situation, does the placement of parentheses have an effect on the evaluation of the expression? So let's compare the two expressions without parentheses. We have 5 square plus 5 times 7.8 plus 4 times 2.49. So if we did not have parentheses and we are solving this, we are again going to solve the exponent first. So that's 5 square. That gets evaluated. Next, we have addition and a multiplication. We're going to do the multiplication first. So that's 5.78. That again is what is inside this parentheses. And the same for the last part of the expression. Though we have an addition, we have a multiplication which gets evaluated first. So that would be 4 times 2.49. So irrespective of whether you have the parentheses or not, as we follow the order of operations, our exponent is going to get evaluated first, followed by the multiplication, and lastly the additions. So in this case, it does not affect the value of the simplified expression. Let's see, there's a check problem here. The check problem is on page 272. Solve this on your own. I'm going to share the solution in a moment. The solution for the check problem is 164.80. Let's look at the extra example problem. In this case, I'm actually going to go over this extra example problem because I did not do the check problem with you. Let's see, Alexis and 3 friends are at the mall. Each person buys a pretzel for $4, a sauce for $1.29, and a drink for $2.08. They also have a coupon for half off of each drink. So to write the expression for this, we're first going to consider how many people there are. So it says here Alexis and 3 friends. So there are a total of 4 people. Now each person buys a pretzel. So let's look at all the expressions, see whether we have all the items, each of the items individually. Our first expression, 4 square, 4 times 4 can be represented as 4 square. A shows the 4 square, B shows the 4 square. C shows 4 times, within parentheses, 3 items. So 4 times 4, that seems to match so far. D also shows 4 squares. So far we have not eliminated any of these options. Next, we look at the sauce. So each person buys a sauce for $1.29. So we have 4 times $1.29. Let's see, A shows 4 times $1.29. B shows 4 times $1.29. C also shows 4 times $29, though it's expressed differently. We've used the distributive property over here. And D also shows 4 times $29. So far, all the expressions still seem correct. And then they buy a drink for $2.08. And let's see, this also says they have a coupon for half off of each drink. A half off would mean you're dividing the price in half. You only have to pay half the price, so that would be a divide by 2. So let's look at it. Our first expression here just says 4 times $2.08. It does not represent the half off, so A is not a correct solution, a correct expression. Let's look at B. B shows 4 times $2.08 divided by 2, which is correct because that's $2.08 divided by 2 represents the half off times 4 for the 4 people. So far, B seems a go. Let's look at C. C does show 4 times 2.8 cents, but if you can look here, the divide by 2 is being applied to everything. Not just the drink, but also the pretzel and the sauce. And lastly, let's look at D. So C is not a correct option. Let's look at D lastly. D shows a divide by 2, but it shows the divide by 2 for both the sauce and the drinks. That's not the correct option. So correct answer here, the expression is one that's represented by B. All right, let's move on. Let's do the applied problem here. This would be page 273 of your book. An art store sells different sized art kits that include crayons and a sketch pad. The table shows the number of boxes of crayons and sketch pads in each kit. A school buys 30 small, 35 medium, and 10 large art kits. Then they return 11 medium art kits. How many boxes of crayons and sketch pads do they have in all? Now the table here shows how many boxes of crayons and sketch pads are in each of the different size boxes. So I'm going to have to move this over to, let's see. What is the task? Make sure you understand exactly what question to answer or problem to solve. How can you approach the task? Let's see whether they have anything for us here. What strategies can be used? So because there's a different number of boxes and sketch pads in these, I'm going to separate the two. I am going to move on to my notepad to continue working on this problem. So I just wrote down the table here, which says in each size box, what is the number of crayon boxes and sketch pads that are available. So let's look at what are the items that they're going to buy. The school buys 30 small, 35 medium, and 10 large. And they then return 11 medium. So let's look at how we're going to evaluate the amount of crayons, the quantity of crayons. We're going to do them one at a time. The number of boxes of crayons is going to be 30 small-sized kits times 16 boxes of crayons in each kit, plus what we have is we buy 35, but we return 11. So we'll be left with 35 minus 11 times 24 boxes of crayons, plus the last one is going to be 10 large times 68 boxes of crayons in the large. So I'm going to work on resolving these expressions individually. Now, in the case of this first one and the last one, we did not really need the parentheses because multiplication has a higher priority over addition, but I still put it just so I can keep things clear and organized. Right? So I'm going to evaluate what's inside this expression. 30 times 16 gives me 480 plus 35 minus 11 is 24. I have 24 times 24 plus 10 times 68 is 680. So this gives me 480 plus 576 plus 680, which is equal to 1,736 boxes of crayon. Next, I'm going to evaluate the quantity of sketch pads. My expression, guys, is going to look pretty similar to the boxes of crayons because they buy the same number of kits. This one kit has both of these. So it's 30 times 20 for the small plus 35 minus 11. This doesn't look neat. 35 minus 11 times 40 plus 10 times 100. As I evaluate these, 30 times 20 is 600 plus 35 minus 11, as we know, is 24 times 40 plus 10 times 100 is 1,000. This would be, I just did what I tell you to not do. Write your 6 clearly. 600 plus 24 times 40 is 960 plus 1,000. So my final answer here is 2,560. I want you to carry on and could you solve this problem a different way? Think about it. We'll talk about it in class. And work on the check problem on page 274 on your own. Pause the video here while you work on it, and I'm going to share the answer. The final answer to that check problem is $92.25. And here's another extra apply problem. Ooh, fun, fun, fun. If you like it, the table shows the chocolate cookies. Pause the video here. Copy this down if you want to work on it. If not, I am going to keep moving on. I will be assigning this exit ticket to you as usual separately. Go work on this. Go work on the exit ticket. And I will see you in class tomorrow. Bye-bye. Ciao, ciao.